Lecture number 1. It deals with the camera, shutter speed, and aperture. The camera we're going to be using is called a single reflex lens camera. It's also known as an SLR. The school actually provides this. With a $200 deposit, you're able to get your own camera for the semester. If you bring the camera back in functioning order and you haven't maliciously destroyed it in any way, you'll get your $200 back. The camera, there's a video that goes over kind of the different functions of the camera, the different aspects of the camera, but to just kind of review that, there's a lens, and in the lens there's a focusing ring and an aperture ring. These lenses can actually be replaced. We're only going to be giving you a 50mm lens, so I'm not going to teach you how to take the camera, the lens off. So inside the lens, again, is the aperture. The aperture is an opening that opens and closes. We talk more about it later during this lecture. Behind the lens, within the camera body itself, is the shutter. The shutter actually opens and closes and allows light to enter and strike the film. That deals with how fast things are recorded. Again, we talk about that later in a little bit more. The viewfinder is where you actually pull the camera up to your eye. That's called the viewfinder. When you're looking through the viewfinder, you're actually looking through the lens. So there's a mirror inside the camera, and the image goes through the lens, strikes the mirror, gets reflected up to another mirror, and then that mirror reflects it to your eye. So it's being bounced twice before it actually enters your eye. That's why it's called a reflex lens, because it reflects. Again, the camera is provided to you. If you have your own, you're more than welcome to use it. This is a film camera, and we're going to be doing a black and white class. We use Ilford 400. You should have already gotten it in your first kit. In the kit that you got from the bookstore. If you haven't been able to get that, just let me know. I'll make sure that they have those available for you. The last thing, so there's 3 things that you need to do to take pictures. You need a camera, you need film, and you need light. And the biggest thing to remember is the brighter the light, the easier it's going to be for you to take pictures. So as a beginner, I would say trying to use as much light as possible is going to really benefit you. So taking pictures outside, taking pictures, like even at the Mall of America, it has some really bright spots in it. But if you're taking pictures in your house, you want to make sure you're getting close to a window on a bright sunny day. It just makes things easier. If you're doing things at night, it gets a little bit more tricky, and I can help you through those situations and teach you how to take pictures at night, but it might just be easier for now to start with taking pictures during the day. Loading the camera. This is a little picture on how to load the camera. There's 3 different types of cameras that we can be loading. I actually have a video on how to load our camera, the camera that is given to you by the school. So please go and watch that. If you have any questions, loading the camera is really important. So make sure that you get that right. If you have any questions, again, talk to me during lab. To get started, there's 3 things that you need to do. There's 3 things that you need to have, that you're able to control, I should say. There's 3 things you're able to control in order to take a picture. That's called the exposure triad. Some people call it the exposure triangle. Those things are shutter speed, aperture, and film. And it's also known as film speed. We use Ilford 400, so you'll never have to change your film speed. So shutter, aperture, film, and light. Those are the things that you need. So how do you work with those things together? The first thing you need to do, there's this little window on top of the shutter speed dial. It should say ISO 400. If it doesn't, I'm not going to show you how to change it. If it doesn't say ISO 400, just let me know. I'll change it for you. The second thing that you need to do when you're focusing, or that when you're taking a picture, is focusing. So inside, when you look through the viewfinder, inside there you'll see a thing called the ground glass. That's the whole picture. There's a micro prism, like it's a circle that looks kind of bubbly, and then inside that circle there's a second circle with a split image. When you take a picture, you need to make sure that that split image is lined up. If it's out of focus, that image will be offset a little bit. It won't look like it actually finishes. So if you look at a straight line going straight up and down, if your picture is out of focus, the line will start, come down to the split focus, and then shift and continue. So it will actually shift out of focus or shift over, and you can tell that it's not in focus. If you move the focus ring until those two lines on a straight line come and are actually complete one another, then you're in focus. Some people have a lot of trouble with focus. If you do have trouble with focus, again, talk to me during lab. I'm able to help you. So after you've set your film speed and made sure that you're in focus, the third thing you want to do is set your exposure. Again, there's 3 things that allow you to set your exposure. Film speed we've already covered. Now you're going to be doing your shutter speed and your aperture. Now, if you want to think of it as a math problem, shutter speed and apertures are variable. You're able to move them between pictures. Film speed is a constant. Over the entire roll of film, you're going to be using the same film speed. But you can move your aperture all the time to help you in any given lighting situation. Shutters start from 1,000. Actually, I think in our camera it goes to 2,000 down to 1 second. And that deals with a fraction of a second. So it's 1/1000th of a second, 1/500th of a second, 1/250th of a second. The second thing that you'll deal with is your aperture. The aperture is the size of the opening located within the lens. So you can make a really big opening, and that's like f1.7, and you can make a really small opening, and that's f22. So those 2 things together with your film speed allow you to set your exposure. But how do you know when your exposure is set correctly? That's what your meter is for. If you pull your camera up to your face, you'll look through and you'll see on the right side of the frame, I believe, there's a little plus, a little green dot, or a little red minus. So there's a red plus, a green dot, or a red minus. This is the meter. The meter actually tells you when the camera is set correctly to record the lighting situation you are in. So if you have a red plus, that means you have too much light that's going to go and strike the film. So you need to reduce that. If you have a green dot, that means you have the correct amount of light. You're ready to take the picture. If you have a red minus, that means there's too little light and your picture is going to be underexposed. So again, green dot means go. Red plus means too much light, and your picture will be overexposed. Red minus, too little light, your picture will be underexposed. So exposure, what is it actually? Exposure is a combination of the intensity of light that reaches the film and the length of the time that the light strikes it. So again, exposure is a combination of intensity of light that reaches your film and the length of time the light strikes it. We actually go through exposure quite a bit, and we have gone through exposure already. Or we'll go through exposure in the second lecture, and we'll talk about it more in depth and how exposure can affect what you're taking a picture of and how it will affect mood and all kinds of stuff like that. So we'll be talking about exposure more in depth as we go through the class. One of the things that helps us set exposure is shutter speed. Again, shutter speed is how fast the light is recorded onto the film. So it actually deals with motion. So when you're taking a picture of something slow, at a slow shutter speed, of something moving fast, like in this picture, the object is going to be blurred. If you're taking a picture using a fast shutter speed with something moving fast, it's going to look like it's frozen in time. So slow shutter speeds allow motion blur to be shown, and fast shutter speeds allow things to be frozen in time. A slow shutter speed is anything really below a 60th of a second. So anything below a 60th of a second is considered a slow shutter speed. And slow shutter speeds should really be you should put your camera on a tripod or some type of solid surface, because even the shake of your body will be captured by the film. So slow shutter speeds, anything under a 60th of a second, you should be using a tripod. Fast shutter speeds are 500, 1,000, 2,000. Those things are able to stop almost anything in motion. A fast moving car will look like it's not even moving when you take a picture at a 2,000th of a second. So those two things really allow how fast an object is being captured. So how are we going to be reading it? So on top of your camera, there's this little dial on our cameras. It's a little circle. It has 2,000, I think it goes 2,000, 1,000, 500, 250, 125, 60, 30, 15, 8, 4, 2, 1, B. The B stands for a bulb. So the bulb means that you're able to open the camera and have that have the shutter open for as long as you're holding the button down. This is how you can take really long pictures. In the example shown in this slide, you'll see that that the camera is actually set at 1/250th of a second. One of the things that you'll notice between 250 between a 500 and a 125. First thing that I need to say is a lot of times I will not say 1/225th of a second. I will just say 125, 250, 500. I'm assuming that you know that it's a fraction of a second. So if you'll notice that between all of those stops, and that's what it's called, any type of a stop is a measurement of light, and a stop is actually denoted through the numbers that we use. So through the shutter speed numbers and through the aperture numbers, that's what a stop is. So if you'll notice that between each stop, it's doubled. So 125, double it, you get 250. 250, double it, you get 500. 500, you double it, you get 1,000. 1,000, double it, you get 2,000. Stops are doubled. Now, sometimes it's a little weird because like an 1/8 of a second doesn't double to a 15th, it doubles to a 16th, but they want to keep it like close to the minute or how we kind of think about minutes. So it's a 60th of a second, a 30th of a second, and then a 15th of a second, which isn't a doubling, but it's close enough. And it's just the way it's always been done. I really don't even know why they changed it like that, but that's what it means. So a slow shutter speed, as I said before, is anything below a 30th of a second. And if you're taking something that's moving fast, like a car, water, anything that's moving quickly, it will cause it to look blurry. And remember, anything that if you take a picture under a 60th of a second, that's how they say it, below a 60th of a second, the camera should be on a tripod. A fast shutter speed is really anything above about a 250th of a second, so above a 250, and it freezes things in motion, as I said before. Now, the way to think about this is I usually use the way to think about this is to think about people walking, right? So somebody walking, you'll be able to stop them, make them stop like they're in motion at a 1/25th of a second. That's going to stop motion of somebody walking. A 500 will stop somebody running, and a 2,000 will stop somebody in a speeding car. So 125 Shutter speed of 125 will make a person look frozen in time if they're walking. 500, a person running. 2000, a person driving a car. Those will all, at those two different things, they'll stop somebody. They'll make it look like they're frozen in time. But there is this little trick you can do when using a slow shutter speed to make something look like it's stopped in motion. So if you're using like a 30th of a second, you actually can make things look like they're stopped. And the way you do that is that the motion has to be going towards the camera. So if the motion is coming towards the camera, then you're actually able to make the object look like it's frozen in time. If you're using like a 15th of a second or a 30th of a second, it will look like it's frozen in time if it's coming towards you. It's when the object goes across the camera. So if it's moving from like left to right or right to left across the view of the camera, that's when motion really gets accentuated. So when motion is coming towards you, it doesn't look like it's moving that much. I mean, think about when you're driving a car and at night and you see these headlights way off in the distance. You really don't know how far they're coming. They just kind of keep coming at you and they don't look like they're moving at all until they get right beside you and then they fly past you, and then it's the same thing in the tail lights. They just kind of keep going behind you and you don't know how far they are away. So as objects come towards you, you can make them look like they're frozen in time with a slow shutter speed, but moving across the plane of the camera from right to left or left to right. That's when motion is really accentuated. There's one last thing that we're going to talk about in shutter speed, and that's this thing called panning. So panning actually makes a really cool effect where the object or your subject that you're taking a picture of is in focus, but the background is completely blurry. And the way that you do this is that you have to actually move the camera at the same speed that the object is moving. So as you're kind of taking a picture, think about when you see those people at a tennis court, at a tennis game, and they're watching the ball go back and forth, like their heads move with the ball. That's what you're doing when you're panning. You're moving your head along with the object, and you're kind of trying to keep that object in the exact same spot inside your viewfinder through the whole motion of the pan. So you're going to start it, and so you'll start moving along with the object. You'll press your shutter speed. Don't stop the camera. Keep moving it, and then the shutter will release, and you should have the object in the exact same spot in the viewfinder from when you start it, when you press the shutter, to when the shutter opened. That allows the background to be blurry and the object to be in focus. If you have some questions, talk to me in lab. I can demonstrate how to do it a little more precisely in lab. All right, so that's shutter speed. Now let's deal with aperture. So aperture controls how much light is let through an adjustable opening in the lens. So inside the lens, there's this little opening, and it's a diaphragm, and it can close down to really small, or it can open up to really large. And that's also controls what's called the depth of field. So a small opening has a large depth of field, and a large opening has a shallow depth of field. It's also a large depth of field is also called deep focus. So large depth of field is deep focus. Small depth of field is called shallow focus. So aperture controls. What is it that is actually happening when you're turning the aperture dial on the lens? And that's where the aperture is located. The aperture is located in the lens. So this chart right here actually shows you how much light is being let in for each aperture. So at f16, a little bit of light is coming through, and it's half as much light as f11. And f11 lets twice as much light in as f16. And you can kind of see as the chart goes. As the hole gets larger, more light is allowed in. Now, the thing that's really kind of weird about aperture is the higher number is the smaller hole. So people get this confused all the time. So f16 is a really small opening. f1.7 is the largest opening our camera has. So Remember, f16, f22 is a small opening. f2.8, f1.7 is a large opening. You have to remember that, and you have to commit that to memory. Those are the two things you just need to remember, that large as the f-stop number increases, the hole is actually decreasing, and as the f-stop number decreases, the hole is increasing. So how do you use all of these things together to take a picture? Shutter speed or film speed will always be set for you. It's the film that you buy. Shutter speed and aperture, those are two things. They're variables. They can always move, right? So you can choose what you want at any given time. You can choose, as long as you have enough light to take a picture, you can choose what setting you want your camera to be at. So this chart actually shows you how these two things work together. And shutter speed and aperture work together to record light. So a slow shutter speed, more light is entering the camera, and you have more of a chance of motion blur. At a fast shutter speed, less light is entering the camera, and you have less of a chance of motion blur. At a small aperture or a really closed aperture, less light is entering the camera, and you have more depth of field. At a large aperture or a open aperture, more light is entering the camera, and you have less of a depth of field. So those are the things that actually are working together. So together with trying to figure that out, you can actually take any kind of picture you want. Here's a good example of how they actually work together in a set of 3 photographs. So the first photograph is taken with a really fast shutter speed, but a very open aperture. And what it allows it to do is the person on the swing actually is frozen in time, but the person in the background is actually really out of focus. The second photo is shot at a 60th of a second at a f5.6. This is kind of a mid-range. The background is starting to get in focus, and the person on the swing is starting to go blurry. So it's really kind of right in the middle. And then at a slow shutter speed at a shutter speed of an eighth of a second at f22, the person in the foreground is completely blown out of, is completely just a blur of motion, but the person in the background is in focus. So these are the things that you have to kind of balance. It's what do you want in focus? Do you care if there's motion blur? Do you not care if there's motion blur? All those things kind of come together to help take a picture. And if you, again, need more kind of instruction on this, come talk to me in lab, and we'll figure it out together. So the things to remember, right, is that you need to make sure that you're loading your camera correctly. If you don't load your camera correctly, you get no images. You also need to make sure that your image is in focus and exposed correctly before you hit the shutter release button. So you got to make sure that you're in focus, and you got to make sure that you got the red light or the green dot in your meter, or else you're not going to have your picture in focus. Shutter and aperture work together, and shutter, aperture, and film speed work together. Shutter and aperture are the variables, and film speed is the constant. Shutter speed records how fast light is recorded. Aperture records how much light is recorded through the lens and also controls the depth of field. And a correct focus and correct exposure are both needed to make a quality image. So they work separately. So even though when you get a good image, you have something that's in focus and exposed correctly, a correctly exposed image can be out of focus, and an in focus image can be incorrectly exposed. They're two separate systems that work together to make a picture. So if you have any questions, talk to me in lab. There is also a couple of other resources that I have put online. So if you need more information, go ahead and click on the link. You can also, if you're still confused, by all means, go and use the internet, find some YouTube videos that will help you try to figure these things out. If you have any questions, send me an email or talk to me during lab.